All right, remember that I said we were going to skip ahead and that we're going to do section 9.6 before we do section 9.5. So when we do section 9.6, it's over factoring trinomials, and we're going to be working with non-plane x squared. What that means is that when we see our trinomials, we're going to be expecting to see them in this format, ax squared plus bx plus c. And a, b, and c are all going to be numbers. So when we talk about non-plane, we're going to talk about having a number here, other than 1, because the ones once we have this pattern down where there's a number here, the problems where there's a 1 become actually much easier. So we're going to start with the harder ones and get easier this time. So when we do these problems, the easiest way for me to show you, without having to show you any guess and check so that you get the right answer every time, is to use this little trick or organizational tool. And there are a couple of different ones that you'll learn over the years, but this is my favorite, that we use an X and we use a box. In the X, at the top of your X is always going to be whatever you get when you do A times C. Whatever that number is, whether it's positive or negative, whatever it's going to be. And then down below, you're always going to put whatever this B value is. So it could be positive or negative, but we're always going to put that B value there. And we're going to look for two numbers to fill in to these two corners. That's what we're going to look for. In our box, we're always going to fill in ax squared here in this first box. Oops, that should be an x. And we're always going to put our constant down here in this box. This diagonal, these like terms, are always going to be composed of these two pieces. And they're always going to add up to b. Now, let's start looking at some examples. The first one I'd like to look at is 5x squared plus 7x minus 6. The first thing I want you to do is notice that it's a trinomial. It's got three terms, right? Three of them. And the second thing I want you to notice is that in front of the x squared, well, actually, really, the second thing I want you to notice is that it's in order. It's in descending powers of x. Because if it wasn't in order, that's got to be our first job, is to put it in order. So we've got a trinomial. It's in order. Then the third observation is the fact that there's a number in front of x squared. In this case, it's 5. So that means we aren't going to be able to take the shortcut. We'll have to take the long way. And the long way says that we're going to make an x, and we're going to need a box. And since we have a trinomial, we're hoping to get a binomial times a binomial, so we'll have a 2 by 2 box, because that's what we're pretty much going to do all the time. All right, now let's go ahead and fill this in backwards. So the c value, the constant, is negative 6, so that's going to go here. The a value is 5x squared, and that's going here. All right, now let's work over here on our x. Remember that our x is always made up of our a times our c, or a leading coefficient times our constant. So 5 times negative 6, that makes this a negative 30. And our b value always goes down below, which in this case is a positive 7. And now we have to figure out how to fill in these blanks. So we need to look for a pair of numbers that multiply to a negative 30 and add to 7. We can think these, but for the sake of our notes, I'll write them down. So we have the pair of things that multiply to negative 30. 1 times 30, 2 times 15, 3 times 10, 4 doesn't go into 30, but 5 does. It's 5 times 6. And that will complete our list because we already have 6 on the list. So now, which pair multiplies to a negative? So one of them's got to be positive, one has to be negative, and adds to 7. Hopefully, this pair right here stands out. You didn't even need this list, I hope. So that if I had a positive 10 and a negative 3, I would satisfy the situation. They multiply to negative 30 and they add to positive 7. We're going to use this positive 10 and we're going to use the negative 3 to fill in our b, or split up our b. We're going to split it into positive 10x and negative 3x. It never matters which one you put where. Never, ever, ever. So now that we have this, now how do we get to our factors, right? Because we're using our box in reverse. So instead of doing multiplication, we're going to do division. We need to use our greatest common factors. So we work from top to bottom and left to right. So let's work the one that's most obvious to us first. 5x squared and 10x, what do they have in common? They have a 5x in common. And then we can say, okay, well that's good. How about 5x squared and negative 3x? What do they have in common? The only thing they have in common is x. And now you've got some choices. You can either do it by division or you can continue with greatest common factors. So 10x and 6, what do they have in common? They only have a 2. And it should be a positive. because I want to make sure that 5x times 2 gives me 10x. But now I need to do this one. Negative 3x and negative 6, what do they have in common? Happens to be a negative 3. Always check those multiplications, right? Negative 3 times x gives us negative 3x. Negative 3 times positive 2 to get negative 6. So that when I factor my trinomial, 5x squared plus 7x minus 6 is equal to, now my quantities are on the outside of my box because I did division instead of multiplication. I have x plus 2 and I have 5x minus 3. Let's go ahead and turn the page and let's work on a couple of the ones that are there for you. The directions say factor each of the following trinomials. FOIL to check. Our first step, and I didn't say it on the previous page, is always, can I pull out a greatest common factor? Can I make this problem even easier? But this first one, I know there isn't a greatest common factor, right? 7, 18, and 8 do not have a common factor. So that to do this problem, I need to use an X and a box. There are other methods that we'll talk about in class, or maybe you've learned one already. But this is the one I like because it doesn't make me have to guess, and my check step is built in. So I've got my X in my box, and if I work my box backwards, I have an 8 as my constant, 7x squared, and then I can work to my x. I always do a times c, so the leading coefficient times the constant, 7 times 8, that's going to give me positive 56. And my b value of negative 18 goes down below. Pair of numbers that multiply to 56 and add to negative 18. Oh, well, the only way for them to multiply to a positive and add to a negative is if they're both negative numbers. And numbers that multiply to 56. Take a moment and make a list if you need to. If you know it, that's awesome. There it is, negative 4 and negative 14. Remember, those two values are the ones that split my b value, so that negative 4x, negative 14x. Again, it never matters how you fill those in. The only thing that will happen if you fill them in different from the way that I did is that your across will be my up and down, and my up and down will be your across. Then we go ahead and we start working on greatest common factors. 7x and negative 14x, well, that one jumps off the page at me. That's a 7x. Oops, I forgot to write down that I was doing division, so I knew which way I solved this problem. 7x times x would give me 7x squared. Then negative 4x and 7x squared, yep, that's what they have in common. I can work across. Negative 4x and positive 8 can have a negative 4 in common. I know that that has to be a negative because I had a positive constant and a negative b value, so I know that they're both going to be subtractions. Greatest common factor between 14 and 8 is 2, or I can do it with multiplication, right? 7x times negative 2 to get negative 14x. So that my solution, my factor, is going to be x minus 2 times 7x minus 4. Why don't you give problem number 2 and problem number 3, give them a try on your own, and then come back and check your work. Pause them and try them on your own. So double check your work in problems 2 and 3. Again, if you're across in my up and down or however, as long as you have a quantity that's x plus 1 and another quantity that's 3x minus 2, you did just fine. Same thing applies here. If you have 5x minus 1 and then x minus 3, your quantity has to match mine exactly, what's inside the parentheses, but whether it's the first set or the second set doesn't have to match exactly. Go ahead and give some more of these problems a try, and in class I'll put the answer key up so you can see the rest of these problems.